Hello everyone, hope all of you are safe and healthy. Welcome to IASbaba's Rapid Revision Series for Prelims 2021. This is session 60 and day 82. And the topic we have is the science and technology, that is the space missions of various space agencies. So these are the hot topics we are going to discuss. That is the Hope, Mangalyaan and Perseverance rover, and then the Tianwen and ExoMars missions. So these are the Mars missions of various space agencies, friends. Then the new Shepard Rocket, then Lucy mission and CAPSTONE mission, then Artemis Program, then the space telescopes, that is the comparison between Hubble and James Webb telescope, then Parker Solar Probe, and then EOS-03 satellite of ISRO, then Gaia and Bepi Columbo, and then Rosetto and Cheops. Now coming to the first one, Hope, Mangalyaan and Perseverance rover. First is the Hope, that is the United Arab Emirates launched its Hope Mars mission aboard a Japanese rocket called Mitsubishi Heavy Industries HIIA. So this Mitsubishi Heavy Industries HIIA, this was the vehicle which carried the Hope's mission, and this was the Japanese rocket. And then Hope is the first planetary science mission led by an Arab country and fourth space mission of the UAE. So these facts we will remember, that is the first planetary mission of a Middle East country, and then the fourth space mission of United Arab Emirates. Then the orbital probe will perform the atmosphere, weather and climate observation with its infrared and ultraviolet spectrometer and high resolution camera. So it has the spectrometer and high resolution camera to study the atmosphere and weather of the Mars. Then this mission is scheduled to last for 1 Martian year, that is the 687 Earth days, or in other words approximately 2 Earth years. Then this mission helps to trace the mechanisms that leach the oxygen and hydrogen out of the Martian atmosphere, and which was previously warmer and wetter with plenty of oxygen. Yes friends, this Mars, earlier it was a plenty of oxygen and hydrogen and it was a wet planet, but now it is a dry planet and all the oxygen and hydrogen are leached out. So what was the reason of leaching out? All will be studied by this Hope mission. So this is all about Hope mission. Here we can take a glimpse of the Hope mission with an antenna, panels, and then the working space of the satellite, etc. Then come to the next one, the Mangalyaan. Friends, Mangalyaan, as we know, it was launched long back, but here we take up only as a comparison. Now the payloads of Mangalyaan. The Mars color camera. Friends, even the Mangalyaan had a camera. Then the methane sensor for Mars. So this was additional to the Hope mission, and methane, it is one of the basic gases for the life sustenance, and hence Mangalyaan basically searched for life sustenance in Mars. Then Lyman alpha photometer. So just like the infrared and ultraviolet photometers, the Mangalyaan mission had the Lyman alpha photometer. Then the thermal infrared imaging spectrometer. So even infrared spectrometer was present along with the photometer. So these two will cater to the particles that are being present in the Mars, and it will study the spectrometry of those particles. Then Mars exospheric neutral composition analyzer. So the neutral atmosphere of the Mars will be analyzed. Friends, we know that it is easy to analyze the charged atmosphere, but it is difficult to analyze the neutral atmosphere, which doesn't emit any electromagnetic waves. So that is why high resolution spectrometers are required to analyze the neutral exosphere. So that is why this MENCA was added as a payload. Then Mars orbiter mission was launched with the help of Polar Satellite Launch Vehicle PSLV C-25. So this C-25 means it is a cryogenic engine, friends. Then the specific objectives of Mars orbiter mission, that is the develop and design the interplanetary mission. Friends, the launching and designing the satellite itself was a great achievement for India. So that was one of the major objectives as well. Then object maneuvers from Earth orbit to Martian orbit. That is friends, this Mangalyaan, it made one orbit around the Earth and then it moves to the Mars. So even this rendezvous was one of the greatest achievements, and that was also one of the objectives. Then maintain the spacecraft in all phases of the mission. So maintenance of the spacecraft was also one of the objectives. Then ultimately study the climate, geology, origin and evolution of the Mars. Then to study sustainability of life on the Mars. So this climate geology was present in the Hope mission as well, but this sustainability of life, this is an additional feature of Mangalyaan over Hope mission. So these are some of the facts regarding Mangalyaan. Then coming to next, Perseverance rover. Friends, Perseverance rover is much more advanced than the Hope and Mangalyaan. We will see how. United States launched a 6-wheeled self-driving rover called Perseverance, and twin rotor helicopter Ingenuity, and an orbiter called Navin. So the current Mars mission of United States, it contained a rover called Perseverance rover, and then a drone or a helicopter called Ingenuity, and then an orbiter called Navin. So here in this figure we can see the Perseverance rover, that is a 6-wheeled vehicle, and then we can see a helicopter which is having the double rotor or the twin rotor, and then we can see an orbiter that is orbiting around the Mars. So these are the important payloads of the Mars mission of NASA. Then the target of this mission is to study the Jezero crater, a site of an ancient river delta. Friends, in Mars, this Jezero crater was a valley wherein an ancient river flowed, and this ancient river will be having great insights for the life existence in Mars. So that is why this mission targets this Jezero crater. Then Perseverance was developed to address the faults of NASA's current Curiosity rover. So friends, currently the Curiosity rover is already on Mars, but it is not working properly because it is having some 24 minutes slack time. That is, whatever signal this Curiosity rover sends, that will reach the Earth only after 24 minutes. So this lag will hinder the simultaneous study of the Mars. So that is why this Perseverance rover will be having no delays. So instantaneously the signal will be transferred. Then the drone helicopter Ingenuity is the first aircraft to fly on the surface of another planet. So this is a great achievement from NASA. Then it also has an experiment designed for generating oxygen out of Martian atmosphere as a proof of concept for future rocket fuel on the red planet. So this helicopter, it also has a mission for generating oxygen in the Martian atmosphere. Friends, in the last HOPE mission we studied that the Martian atmosphere is lacking oxygen, and now this helicopter, it is conducting an experiment to produce oxygen on the red planet. So this will be another great achievement, and it can prove the life sustenance and the re-triggering of the life sustenance on Mars. Then Perseverance is going to drill into Mars and collect samples of rock that may contain evidence of life. So this is going to drill into the Mars and collect the evidence. Then the follow-up plan of this mission is to collect these samples from Mars and return them to the Earth. So there is a mission going on to return these samples to the Earth. So whatever satellite they have sent, that has to come back to Earth in order to give the samples that were collected. So a great mission. We will see to what extent it will succeed. So this is all about the Perseverance rover and the NASA's Mars mission. Then come to next one, the Tianwen and ExoMars. First one, the Tianwen, China's first ever independent mission to Mars, the Tianwen-1, which was formerly known as Hoaxing-1, which means questions to heaven, was launched. So friends, Tianwen-1, which is going to question the Mars, has been launched, and then the launch craft consists of an orbiter, a lander, and a 240 kg rover. So just like the NASA's mission, it also has an orbiter and a rover. It doesn't have a helicopter, that's all. So lander is necessary whenever a rover is sent, friends, because this lander is the one which lands the rover on the Martian soil. Then the orbiter carries radar and a camera to measure and map the Mars's morphology, electromagnetic and gravitational fields, and ionosphere. So we measured exosphere, which was neutral, and this Tianwen, it is going to measure the ionosphere, and it is also going to measure the electromagnetic and gravitational fields and the morphology, that is how Mars has morphed from a wet planet to dry planet. Then the rover will operate for 90 Mars days, and it will map soil characteristics and water ice distribution, and also study the climate and environment. So overall study are being done by Tianwen. Then the orbiter will use a high resolution camera to search for a suitable landing site somewhere in the Utopia Planitia region. So this Utopia Planitia, this is a region on Mars, and on that region this rover is going to land. So this is all about the Tianwen. Then come to next, ESA's ExoMars. Friends, about ExoMars, it is a joint endeavor between European Space Agency and Russian Space Agency Roscosmos. So this is a joint mission, not the solo of ESA. Then the components of the mission, the program consists of a trace gas orbiter, and then Schiaparelli, an entry, descent and landing demonstrator module. So friends, Schiaparelli is mainly a lander and trace gas orbiter is a orbiter. Then the TGO searches for evidence of methane and other trace gases of the atmosphere of Mars. So methane is studied just like Mangalyaan by this ExoMars as well. Then the Schiaparelli probe crashed during its attempt to land on Mars. Yes friends, this was a failure because the lander, it crashed down instead of smooth landing. Then the second mission, comprising a rover and a surface platform, is planned for 2022. So now not only the lander, a rover is also sent and a surface platform is also sent, so that it acts as a stage for the rover to work. Then together they will address the question of whether the life has ever existed on Mars. So both the rover and this surface platform, they will do some research and they will see whether the life exists on Mars. So ultimately friends, almost all the missions, they look into the gravitational field, magnetic field, then the atmosphere, ionosphere, exosphere, and also the life sustenance on Mars. So summarily, almost all missions are aimed towards the single goal, that is settling on Mars. So this is all about the Mars missions. Then come to next one, the new Shepard rocket. Friends, Blue Origin launched its first crewed mission aboard the new Shepard rocket. So Jeff Bezos, he himself went to space with this rocket and then aboard the new Shepard rocket system. It was named after the astronaut Alan Shepard, that is the first American to go to space. So this man will be remembered along with the rocket. Then the new Shepard is a rocket system developed by the Jeff Bezos space company Blue Origin. Yes, we know that. Then the functions of this Shepard rocket is that it takes astronauts and research payloads past the Kármán line. Friends, we know that Kármán line is an internationally agreed boundary line out of which we consider as a space, not as the Earth's atmosphere. So beyond this Kármán line, this rocket will take the human beings, and mainly the researchers and the payloads for the researchers will be taken out of this Kármán line from the Earth's surface. Then it aims at providing easier and cost-effective access to space for academic research. So this is not only easing the research, but it is also providing a cost-effective access for the space. Then it will also allow space tourists to experience microgravity by taking them 100 kilometers above the Earth. So this is also a tourism oriented mission, and we will see to what extent this space tourism will flourish. So this is all about the Shepard rocket. Now coming to its interior design. Friends, the Shepard rocket consists of two parts, that is the cabin or capsule and the rocket or the booster. Friends, in the last slide we had seen the cabin and the booster. So here this is the cabin or capsule and this is the booster. Now come to more facts. The cabin or capsule can accommodate experiments from mini payloads up to 100 kg. So up to 100 kg it can carry. So experiments of 100 kg can be carried by the capsule. And then also it can house 6 people. So here we can see various seats that are arranged inside the capsule, and it can hold 6 people at a time. Then capsule separates from the rocket before crossing the Kármán line, after which both vehicles fall back to the Earth. So friends, here both the vehicles are falling back to the Earth. They are not going to float in the space. So this will not be a space junk. They are recyclable vehicles. Then there will be no pilot as the capsule is fully autonomous. So this is a fully autonomous spacecraft. Then the system is a fully reusable mission. So this reusability is one of the great economic advantage for the space research and space tourism. Then after its separation from the booster, the capsule free falls in the space and lands back with the help of a parachute. So this capsule, it will land with the help of a parachute. Then while the booster performs an autonomously controlled vertical landing back to Earth. So this booster have to be controlled land to the Earth. So this cannot be landed by a parachute because it is too heavy. So this is a brief account of the new Shepard rocket. Then come to the next one, the Lucy mission and the CAPSTONE mission. First one, the Lucy mission. Friends, there are a swarms of Trojan asteroids associated with Jupiter and are thought to be remnants of the primordial materials that formed the outer planets. So friends, there were some outer planets beyond Jupiter, and the remnants of those planets are said to be orbiting around the Sun in the Jupiter's orbit. So these are called the Trojan asteroids. Friends, Trojan asteroids means those asteroids which trail a planet. So here these asteroids are trailing the Jupiter, that is why they are called Trojan asteroids, and these asteroids are different from those asteroids that are present in the asteroid belt between the Mars and Jupiter. Then the Trojans orbit the Sun in two loose groups, with one group leading ahead of Jupiter in its path and other trailing behind. So there are two groups, that is one leading the Jupiter and other trailing the Jupiter. So friends, here we can see Jupiter here, and this group is leading the Jupiter and this group is trailing the Jupiter. And here we can see the mission which is researching on those asteroids. Then coming to more facts, Lucy will be the first space mission to study the Trojans. Yes friends, this will be the first mission to study the Trojans, but however there are several missions that have sent to study the Jupiter itself. So like Juno mission, so these will study Jupiter, but however this Lucy mission, it will study the asteroids that are leading and trailing the Jupiter. Then Lucy will launch in October 2021, and then after boosting from Earth's gravity, it will complete a 12-year journey to 8 different asteroids. So it is having a 12-year long journey, and it will visit 8 different asteroids, that is a main belt asteroid within the belt between Mars and Jupiter, and then 7 Trojan asteroids. So 8 asteroids it is going to visit. Then Lucy will give us our first close-up view of all the 3 major types of asteroids, that is the C, P and D types of asteroids. Friends, there are 3 types of asteroids in these Trojan asteroids, that is the C, P and D, and we have not studied all the 3, and now this Lucy mission is going to give the first glimpse of all the 3 types of asteroids. Then Trojans are thought to be abundant in dark carbon compounds. So these are rich in carbon compounds. That is why the life sustenance can be predictable. So that is why the study is being taken up. Then they are probably rich in water and other volatile substances. So even they are said to be rich in water. So that is another proof for life sustenance. So all these things will give us great insights for how life evolved in the earth as well. So that is why it becomes important. So this is all about the Lucy mission. Then come to next, the CAPSTONE mission. Friends, CAPSTONE is expected to be the first CubeSat to fly in the cislunar space, that is the orbital space near and around the moon. Yeah friends, there are several orbits like the helicos orbit, then the elliptical orbit, then the circular orbit, equatorial orbit, etc. The same way cislunar orbit is one of the orbits, and this is around the moon. And this CAPSTONE, it is a CubeSat or a small or the microsatellite that is going to orbit in the cislunar orbit. Now, a microwave oven sized CubeSat will test a unique elliptical lunar orbit as a part of cislunar autonomous positioning system technology operations and navigation experiment. So this is basically the cislunar experiment for positioning and navigation. So how the satellite will be positioned and how it will navigate in this cislunar orbit is the solo aim of this mission CAPSTONE. That is why the abbreviation itself is kept as CAPSTONE. Then it is a precursor for the Gateway, a moon orbiting outpost that is a part of NASA's Artemis mission. So Artemis mission we will study in the next slide. So this CAPSTONE mission will be a precursor for the Artemis program, that too a precursor for the Gateway, which is a part of Artemis program. So we will discuss this, wait for a while. Then this cislunar orbit is formally known as a near rectilinear halo orbit, or the NRHO is significantly elongated. So friends, just like the elliptical orbit, the cislunar orbit is elongated, but however in the cislunar orbit the moon appears very nearer to the elliptical orbit. So somehow it will be likewise friends, but however in the elliptical orbit this orbit will be further centric, that is the moon lies somewhere in the center. So the elliptical orbit will be like this. So we will see how effective will be the cislunar orbit for the orbiters around the moon. Then it is located at a precise balance point in the gravities of Earth and the moon. So this cislunar orbit will place the satellite in a position that is exactly equivalent to the gravity of Earth as well as moon. So that is why it is of great importance, and this position it offers stability for the long term missions like Gateway and requires minimal energy to maintain. So at this position, at the cislunar orbitic position, if we place the satellite, then we will be requiring minimum energy to navigate the satellite. So that is why to save the energy this orbit has been discovered. We will see to what extent this CAPSTONE mission it will research on the cislunar orbit and how it will become the precursor for the Artemis mission. Now come to next one, the Artemis program itself. Friends, why was it in use? Because NASA wants to send the first woman and next man to the moon by the year 2024 via the Artemis lunar exploration program. So this Artemis program is basically related to research on the moon, and as a part of the mission it is sending women and men to the moon. Now about the Artemis program, Artemis stands for acceleration, reconnection, turbulence and electrodynamics of moon's interaction with the sun. So almost all the things related to physical orbiting, that is the acceleration of the speed, reconnection, then turbulence in the orbit, then electrodynamics, that is the electromagnetic and gravitational signals, all these will be studied with respect to moon's interaction with the sun. Then the mission was named Artemis after the Greek mythological goddess of the moon. So this Artemis it comes from the Greek word which is also the name of a goddess in Greek. Friends, then Artemis is an extension of all the lunar missions of NASA that sent 12 American astronauts to moon between 1969 and 1972. So the 12 American astronauts have already landed in the moon. So now this Artemis mission is going to land 13, 14, 15 and other astronauts in the future. Then objective. The main objective is to measure the effect of sun's radiation on rocky moon where there is no magnetic field to protect it. Yes friends, we know that the solar winds will be emitted by the sun again and again, and earth is protected by the magnetic field of the earth. But however, moon doesn't have a magnetic field. So then how these solar winds they protect the moon? So this is the area of interest of Artemis, and that is what they are going to study there. Now coming to mission, the NASA's new rocket called the Space Launch System will send astronauts aboard the Orion spacecraft to the lunar orbit. So the name of the rocket is the Space Launch System, and the name of the whole spacecraft is the Orion spacecraft. So all these they will send the astronauts to the moon, and then once astronauts dock Orion at the gateway, a small spaceship in orbit around the moon. So friends, this Orion it will take the people, the astronauts, to the moon's orbit, and there will be a spaceship called the gateway, and these astronauts they get down from Orion and then they will enter the gateway and then they will sit into it, and then the astronauts will be able to live and work around the moon. So they will live and work around the moon within this gateway. So they will go with the Orion like a bus, and then they will take the taxi. So taxi is the gateway, and this taxi it will revolve around the moon. So within the taxi they will perform their research operations. Then and from the spaceship astronauts will take expeditions to the surface of the moon. So this spaceship it will go to the surface of the moon, and then it will enable the astronauts to get into the surface of the moon. So likewise from the ship to the taxi and then to the surface of the moon. This is how the journey goes, and the research will be studied based on the magnetic field of the moon. So this is a brief account on Artemis program. Then come to next one, space telescope, that is the Hubble and James Webb telescopes. First one, the Hubble telescope. Friends, the Hubble space telescope is named after the astronomer Edwin Hubble, and then it was launched in 1990 and is still operational. It is expected to decay by 2030 and 2040. So it is under operation till now, and it is going to decay by 10 to 15 years from now on. Then Hubble features a 2.4 meter mirror, and its four main instruments include ultraviolet, visible and near infrared regions of the electromagnetic spectrum. So friends, here it has a 2.4 meter mirror. Friends, why mirror is needed? Because to reflect the light rays into the telescope. So here we can see the mirror which is attached, and it is 2.4 meter in length. So this will reflect the rays into the telescope, and the telescope will be able to view the pictures. And then this telescope is capable of working under the ultraviolet, visible and near infrared regions of electromagnetic spectrum. So in all the three regions of the spectrum, this telescope is capable of working. Then it is one of the largest space telescope which can perform versatile missions. So it can perform several missions like the researchers as well as telescopy. Then with the ongoing construction of 30-meter telescope, this Hubble Space Telescope will no longer be the largest light vision telescope in the world. Yes friends, so this 30-meter telescope, it will be the largest as far as the light vision is concerned. Or in other words, this 30-meter telescope will be the largest telescope that is working under the visible range of the electromagnetic spectrum. So this is the inference we can draw from this. Then come to next, the James Webb telescope. Friends, this James Webb telescope, it is an orbiting observatory that will complement the discoveries of the Hubble telescope. Yes friends, this is also an orbiting observatory just like the Hubble telescope. Then it will complement the researches of the Hubble telescope. It will carry forward all the achievements of the Hubble. Then it is an international collaboration between NASA, European Space Agency and Canadian Space Agency. So these three nations, USA, Europe and Canada, they are contributing to the mission. Then comparison between Hubble and James Webb telescope. Webb will observe primarily in the infrared. Friends, we knew that Hubble Space Telescope, it will work in visible, infrared and ultraviolet regions, but this James Webb telescope, it will work only in the infrared region. Then Hubble's capabilities are in the ultraviolet and visible part of the spectrum. Yes, we discussed that. Then Webb telescope will have an approximately 6.5 meter diameter primary mirror, but however the Hubble's primary mirror, it was much smaller with a 2.4 meters. So friends, this Hubble telescope will be having a 6.5 meter diameter mirror, but this is very large compared to the 2.4 meter diameter mirror of the Hubble telescope. So friends, here we can see the 6.5 diameter mirror, and this will enable more light rays to enter into the telescope, and thereby the resolution of the images will be more compared to the Hubble's telescope. So that is how James Webb telescope will be having more precise images rather than the Hubble telescope. Then the Hubble Space Telescope, it orbits around the Earth, but however James Webb telescope will not actually orbit around the Earth, but instead it will sit at the Earth Sun L2 Lagrange point, that is 1.5 million km away. Yeah friends, the Earth and Sun, they have several Lagrange points. So this is one Lagrange point, and then this will be the other Lagrange point. So there are 5 Lagrange points between the Earth and Sun, and these Lagrange points, they will be having the equitable force in the gravity between the Earth and the Sun. So in one of the Lagrange points, that is in the L2, this is going to rest and it is not going to orbit. And as these Lagrange points, they will be having the net gravity as 0. So there is no need for the telescope to orbit. So this is also another characteristic of James Webb telescope. So in all the directions, James Webb telescope will be having high capability, that is in the infrared region. Friends, we know that infrared rays, they will travel for a longer distance without distortion. So this infrared telescopy is more effective. Then it has a larger primary mirror with a larger diameter, and it is not going to orbit, it is going to rest in a Lagrange point. So these are the differences. Then come to next one, the Parker Solar Probe. Friends, why was it in news? Because the Parker Solar Probe, it marks the 7th successful swing around the Sun. So friends, Parker Solar Probe, it is a probe to the Sun, and this probe, it was aimed at making the swings, that is entering into the Sun's atmosphere and then coming back. So now it has made the 7th swing, and we will see how many further swings it makes. Now about the mission, the Parker Solar Probe will travel through the Sun's atmosphere closer to the surface than any spacecraft before it. So this is the first spacecraft to go to such a nearest distance to the Sun, and no other spacecrafts have done it before. Then, facing brutal heat and radiation conditions, its aim is to guide humanity with the closest ever observations of the star. So automatically, as it moves to such a depth, it will give high precision images and data that are necessary to study the Sun. Then Parker Solar Probe has 3 detailed science objectives, that is to trace the flow of energy that heats and accelerates the solar corona and solar wind. So what is the energy that heats and accelerates the solar corona and solar wind? Then determine the structure and dynamics of the plasma and magnetic fields at the sources of the solar wind. So inside the Sun, there will be the source from where the solar wind emits. So there the materials will be in the plasma state. So the dynamics of the plasma state and the magnetic fields within and around the plasma state, all this will be the aims of the Parker Solar Probe. Then explore mechanisms that accelerate and transport the energetic particles. So what is the energy that accelerates the solar wind particles and other photons? So basically the emergence of solar wind, the energy behind the emergence of solar wind, and then the energy behind the heat and light of the Sun are the main aims to be studied by this Parker Solar Probe. So this is all about the probe. Then come to next one, EOS-03 satellite. Friends, recently the ISRO has suffered a loss of an important Earth observation satellite, that is the EOS-03, when the GSLV rocket carrying it malfunctioned. So due to malfunctioning of GSLV, this EOS-03, it failed to be launched into the space. Now the key highlights, the launch was supposed to place the EOS-03, an Earth observation satellite, into the geostationary orbit. So friends, the geostationary and geosynchronous orbit, the difference you revise here itself. Then the mission could not be accomplished as intended because the cryogenic upper stage ignition did not happen due to technical anomaly. So friends, the glitch was majorly in the cryogenic part. Then about the geoimaging satellite EOS-03. It is a geoimaging satellite of Earth observation from the geostationary orbit. So geostationary orbit means it will be in the equatorial plane and it will orbit in a speed which is very much equivalent to the Earth's rotation speed. Then it consists of capabilities including imaging the whole country 4 to 5 times daily. Then in addition to the natural disaster, EOS-03 would also enable monitoring of the water bodies, crops, vegetation condition, forest cover changes, etc. So friends, as it will be stationed to the correct line of sight with India, so it can observe the nation 4 to 5 times in a day, and it can assess the water bodies, crops, vegetation and other conditions. Then it would enable near real-time monitoring of natural disasters like the floods and cyclones. So other than crops, it can also monitor the natural disasters. So this is all about the EOS-03 satellite which failed to be launched, but however in the future it will be launched for sure. Then come to more facts about the GSLV Mark III satellite launch vehicle. Friends, it is capable of launching 4-ton satellites in the geosynchronous transfer orbit. So friends, we know that this geosynchronous transfer orbit is very much nearer to Earth rather than the geosynchronous orbit itself. So this geosynchronous transfer orbit is the first stage where the satellite is placed, and then the satellite is boosted for the geosynchronous orbit. So up to this orbit, a payload of up to 4 tons can be launched and can be positioned via this GSLV Mark III launch vehicle. Then up to 8 tons in a low Earth orbit, enough to carry a manned module. So friends, to the low Earth orbit, which is further nearer than the geosynchronous transfer orbit, this GSLV Mark III can place up to 8 tons of payloads. Then it is India's first fully functional rocket to be tested with a cryogenic engine. So friends, this was the first vehicle to be fitted with a cryogenic engine. Friends, we know that cryogenic engine means that which works via liquefied hydrogen and oxygen, thereby emitting water as the byproduct. Then the 640-ton rocket, equal to the weight of 200 fully grown Asian elephants, is the country's heaviest but the shortest rocket with a height of 43 meters. So it is the heaviest, friends, but it is the shortest. So it is called the Fat Boy. But however, it is not having so much of height, and we will see PSLV how much height it is having. Then come to more facts regarding the GSLV. It is a 3-stage vehicle with 2 solid motor strap-ons, that is S200, and a liquid propellant core stage and a cryogenic stage C25. So it is having the solid, liquid and cryogenic stages. So this third stage, that is the C25 stage, it malfunctioned. That is why the EOS-03 satellite couldn't reach the orbit. So this is all about the EOS-03 satellite. Then come to next, the Gaia and Bepi Columbo. First one, Gaia. Friends, Gaia, the global astrometric interferometer for astrophysics. So this is atmospheric interferometer. So this basically studies atmosphere and then draws the inferences. And then it is a European Space Agency astronomical observatory mission. Then its goal is to create the largest, most precise 3-dimensional map of Milky Way by surveying about 1% of the galaxy's 100 billion stars. So this is going to study the stars of Milky Way. But how many? It is only 1% of those 100 billion stars that are revolving around the Milky Way. Then Gaia will detect and very accurately measure the motion of each star in its orbit around the center of the galaxy. So these stars, they are rotating around the center of the galaxy, and the detailed study of these stars will be conducted by the Gaia. Then each of 1 billion stars that Gaia studies will be observed on an average of 70 times over 5 years to create a record of the brightness and the position of each star over time. So a detailed study of 70 times and 5 years will be taken up, and this will be a great insights for the origin of universe, origin of galaxy, origin of stars, etc. So this is all about Gaia. Then come to next one, Bepi Columbo. Friends, the highlights of Bepi Columbo are: the mission Bepi Columbo consists of 2 satellites launched together, that is the Mercury Planet Orbiter and the Mercury Magnetospheric Orbiter. So friends, it is basically a study on Mercury planet, and it is having a planet orbiter and a magnetospheric orbiter. So one will orbit the planet and another will orbit the magnetosphere of Mercury. Then the spacecraft Bepi Columbo was launched on Ariane 5 rocket. So basically a French rocket, and this will arrive on Mercury in 2025. So it has not yet arrived. It will arrive in the 3 to 4 years in future. Then the mission is a part of Horizon 2000 Plus program of European Space Agency and was the last mission of the program. So this Horizon 2000 Plus we will study a bit later, and this Bepi Columbo was a part of the mission. Then objectives of the mission: to study the origin and evolution of Mercury, then to investigate the exosphere of Mercury, its composition and dynamics, then to study the magnetosphere of Mercury. So this magnetosphere orbiter, it will study the magnetosphere. Then to verify relativity theory of Einstein. Friends, the relativity theory, it basically says why the small planets, they orbit in the inner orbits and larger planets, they orbit in the outer orbits. So by studying why the Mercury is orbiting in the inner orbit, it will verify the Einstein's theory of relativity also. Then Horizon 2000 Plus, what is this? The missions under the Horizon 2000 program were the Huygens, Rosetta and Gala. So this Huygens, Rosetta and Gala, they had their own objectives and they were a part of this Horizon 2000 program. Then the mission launched under the Horizon 2000 Plus were Gaia, Lisa Pathfinder and Bepi Columbo. So friends, Gaia we studied, then Lisa Pathfinder, it is a geographical wave experiment done in the space. And then this Bepi Columbo we are studying right now, it is a research on Mercury. So this is all about the Horizon 2000 and Horizon 2000 Plus and the Bepi Columbo overall. Then come to next one, the Rosetto and Cheops. First one, Rosetta. The Rosetta spacecraft is a project of European Space Agency launched on March 2nd, 2004. So it was launched in 2004 long ago, and after 10 years of its journey, Rosetta dropped its lander Philae onto 67P or Churyumov-Gerasimenko, a comet. So this mission was basically to study this comet Churyumov-Gerasimenko, and it has dropped a lander called Philae onto this comet on the year 2014, that is after 10 years of journey. And with this landing, Rosetta became the first mission to both orbit and land on a comet. So till now, no landing or orbiting a comet has been taken place, and this Rosetta will be the first one. And then the spacecraft is named after Rosetta Stone. Friends, Rosetta is a stone, and this comet, it resembles the stone. So that is why this Rosetta name is kept to this mission. Then it has main elements, namely the Rosetta Space Probe Orbiter, then Philae Robotic Lander. So the orbiter is orbiting and the lander has landed already. Then objectives: to document how the comet changes and reacts to a close encounter with the sun. So the reaction and interaction of the comet with the sun. Then the output data will help the scientists to learn more about the origin and evolution of our solar system. Yes friends, we know that the dust of the comets, it will bear a great insights to the evolution of solar system, and thereby we will learn a lot about evolution of solar system while studying this comet Churyumov-Gerasimenko. Then, and the role of comets may have played in seeding Earth with water and perhaps with life. Friends, we know that Earth was full of methane, but how this oxygen came in? So it was believed that some comets might have introduced oxygen into Earth's atmosphere. So by studying the comet, we will get to know how oxygen actually came into Earth. So we have several benefits out of this Rosetta. We will see to what extent it will fulfill the dreams of the astronauts and researchers. So here we can see Rosetta, that is orbiting around the Churyumov-Gerasimenko comet. So this is the comet and this is the orbiter. Then come to next one, the Cheops. Friends, Cheops, the characterizing exoplanet satellite, is a new telescope going to be launched by the European Space Agency. So this satellite is a telescope and this will study the exoplanets. Then it is a mission for the study of exoplanets rather than a discovery mission. So it is going to study the exoplanets only. Then it will lift off as a secondary passenger on a Soyuz frigate rocket. So the primary passenger might be any other mission and it is a secondary passenger in this Soyuz frigate rocket. Then it is the first mission dedicated to search for exoplanetary transits by performing high resolution or high precision photometry on bright stars already known to host the planets. So what this mission does, it searches for the photons that are emitted by the stars. So that is called the photometry, and by the ultra high precision photometry, it will get to know the planets that are revolving around those stars, and it will see which are the stars which are capable of sustaining the life, thereby studying the exoplanets. Then the mission objectives: to measure the accurate sizes of Earth through Neptune sized planets. So it is searching basically those planets which are to the sizes of Earth to the sizes of Neptune. So those medium sized planets which are capable of sustaining life are being researched by this Cheops. And then to measure light cores of hot Jupiters to see how energy is transported in planetary atmosphere. So friends, we know that our solar system's Jupiter is a cool Jupiter and almost all the liquids have dried up. But however, there are some hot Jupiters which have fluids as well as the gases, and those hot Jupiters are being researched and the light curves on the Jupiters are studied so that how energy flows through these planets will be tracked and traced. And friends, after studying all those things, this Cheops, it will combine the sizes of the planets and the masses of them, and thereby it compares how the mass and size will vary. So friends, there is specific size and specific mass on which the life is sustainable. So on that mediate size and mass, this Cheops is researching on. Then to research for key molecules in the planet's atmosphere. So those key molecules which are life sustaining, so those are the areas for which Cheops is searching for. So basically an Earth-like planet of Earth size and Earth's mass and some molecules that are very much essential for sustaining of both the planet and the life within the planet are the aims of this Cheops, and this is an ESA sponsored telescopic satellite. So this is all about the Cheops. Then coming to the last part. Friends, one great lesson we learn from the astronauts is that to reach the new heights, to reach the new distances, and to explore the new worlds every day. So taking a cue from those astronauts, we will reach the new heights in the life, and at the end of the day, we will reach the peak where no one has ever gone, and we will leave the trail behind for our posterity to rise up to such a level of excellence. So do it. All the very best. Good luck, friends.